All right, now we're going to look at rational functions where the degree of the numerator is greater than the degree of the denominator. Okay, so we're going to look at the end behavior first. So if f of x equals n of x over dx, this could be like a quartic, and this is a quadratic, something where the degree of this is higher than this. So let's take a look at the end behavior. I'm going to use a similar approach to before, where we're multiplying by 1 over x to the something. Okay. So let's try an example here where you've got f of x equals to, say, x cubed plus 4 over x plus 1. Okay? And what we're going to do for this one, to see what it looks like at the end behavior, so as x goes to infinity and negative infinity, okay, so what happens to y? That's what I mean by end behavior. Then, what happens to y? Y goes to question mark here. What happens to it? So what we're going to do is multiply the top and bottom of this by 1 over, and this time the degree, x to the degree of the bottom. So it's just going to be 1 over x. So whenever you're doing this end behavior, you multiply by 1 over x to the whatever has lowest degree, the top or the bottom. In this case, it's the bottom. So I'm going to say that f of x equals x cubed plus 4 over x plus 1. And I'm going to do 1 over x, 1 over x, multiply the top and the bottom. And that's going to equal x squared plus 4 over x on the top. And then it's going to be 1 plus 1 over x on the bottom. And this is okay, that it doesn't equal, you can't have x equal to 0 looking at end behavior, because I'm looking at when x goes to infinity or negative infinity. So we can do this. Now, as x goes to plus or minus infinity, this piece turns into basically 0, and 1 over x turns into 0 as well. So these become negligible. X squared plus 0 over 1 plus 0 is just x squared over 1. So we can say that it's approximately x squared over 1, which equals x squared. Now the end behavior for x squared is fairly obvious. We know that that looks like a quadratic. So we don't know what it looks like in the middle here, but we know that x squared goes like this and like this when x is really large, negative, or positive. So that tells us the end behavior is something like this. Now what happens when the degree is something, the degree difference is something different? So this, the degree of the top is cubed, the degree of the bottom is 1, so it ends up being their difference in degree here. So x squared is the difference of their degrees. And we know what x squared looked like. So we don't really have to do this anymore. So let's just try and do one more example so you get the idea. What if f of x equals negative 2x x cubed plus 2x minus 1 over x squared plus 5. Okay, so if we multiply the top and the bottom of this by, instead of 1 over x, well, we're going to go with the lowest degree here, which is x squared. We're going to multiply it by 1 over x squared. Okay, on the top and the bottom. And 1 over x squared times negative 2x cubed, well, that's going to equal negative 2x. This times 2x over x squared is going to be plus 2 over x, negative 1 over x squared. Okay, and then x squared times 1 over x squared is 1, and then plus 5 over x squared. And hopefully you see what's happening here. The bottom, you'll get a constant here, and then plus 0 basically. And then as x goes to plus or minus infinity, this is approximately equal to, well, this goes to 0, this goes to 0, this goes to 0. So it's just going to be negative 2x over 1. Okay? And we know what this is. This is basically negative 2x. We know what the end behavior of this looks like. It's just a line. So y equals negative 2x has a slope of negative 2. And so in the middle we don't know what's going on, but on the way out at negative infinity and infinity, you're basically going to have it going down, because negative 2x goes down like this. So it's going to go like this and like this. Okay, and this is a special type of difference because the end behavior is linear. And this line here becomes basically an asymptote. Non-horizontal, non-vertical asymptote. It's called an oblique asymptote. And I'll look at that a little later in another video. Okay, so the difference between the numerator and denominator, the degrees, will tell you what type of end behavior you're having. So when the top is bigger, you subtract the bottom one, and then it'll have the end behavior of that type of function. Now you got to take into consideration the signs here, because negative x cubed would have a different one than x cubed, for example, right? It goes the opposite ways. So that's how you look at the end behavior for this.